Welcome back to Man from the Mist. For those of you who's new, my name's Barry. Today we're going to put the power supply to the pump to test it and see if it runs, because our capacitor has turned up 3 microfarads, and I can hear you asking, how did you arrive at 3 microfarads to operate this pump? To answer that, couple of minutes, let's pop back into the office on the computer and we'll show you the calculations that I've used and where I've gotten my numbers from to produce that result. Working out the size of a capacitor. We need to work out the size of the capacitor so that we don't overpower or underpower one motor. First of all, we need to know the power rating of the motor in kilowatts. If you look at the image of the lathe, it doesn't really give you that. It doesn't give you a lot of information, but it does give you amps and volts. From amps and volts we can deduce the power of the motor. Up here, first piece of the calculation, power equals volts times amps. So P equals V times I. P is 230 times 0.22 for amps. So the power rating of this motor is 50.6 watts. Multiply that by 1,000 to get it into kilowatts, because as we can see in the later calculation, we need the power to be in kilowatts. Now moving on. To calculate the size of the capacitor that we require, we 2 formulas we can use. Either 265 times nominal current divided by operating voltage, or 70 times the motor power in kilowatts. Why does it need to be 70? Because for every kilowatt of a motor's power you require 70 microfarads of capacitance. So if we divide 70, if we times 70 by the motor power, it gives us the size in microfarads of the capacitor that we will require. So let's look at formula 1. 265 times 0.22 divided by 230. 2.539 microfarads. Number 2, which is 70 times 0.056 kilowatts, 3.92. So you can see in the calculations, I don't understand why we are getting different numbers. There is 1.4 farads difference in that. I've gone for something in the middle, which was 3 farads. But I really don't understand why we get a difference in the numbers. You would have thought in mathematics and in physics, if you come at a problem from 2 different angles, you should always end up with the same result. And for some reason we don't with this one. Anyone out there who knows why we haven't got this as the same result, or even in a closer result, because for such a small number, that's a massive difference, isn't it? It's like, it's almost 50% difference from the first calculation to the second calculation, almost 50%. So if you know the answer, let us know, please. Okay, let's pop back to the garage now. Let's crack on, get this wired up, see if it runs. And we'll do some measurements on the voltage on the 3 legs to see what results we get. Back in a minute. So that's where our numbers come from. Let's put the practicalities together and see if it actually runs here. So what we've done is, as I say, we've got 3 microfarad capacitor. This is a run capacitor. 2 leads on it. And there's no negative and positive on these, so it doesn't matter which way you put these. But however, we are going to use brown to brown because it just makes common sense and life easier, doesn't it? So we've got my capacitor. I have made up a very simple lead with 3 terminals on the end. Now these eyes are too big for this, but it's all I've got. I haven't got any smaller eyes. However, it'll do for this little test. And then afterwards, when we put this back in the machine, the idea is we're going to use the existing wiring that's in the machine, because it's already on a set of glands and seals, and we'll fish it out at the switch and we'll get a 230 supply to it. Might even think putting the inverter in the control box and just running the 230 supply from the isolator to the main switch in the machine, so it goes back to all being self-contained. Just a thought, just a thought. Right, so as in the diagrams, this is what terminal, this is what first terminal, second terminal, third terminal in terms of the capacitor and these leads, and earth down here, earth. So first thing we're going to do, we're going to take our brown, which is it's classed as your first phase or your live. So we're going to pop our brown onto there. I'm going to get our capacitor. I'm going to put it on this way. We're going to pop the brown on top of it. I'm going to put a little washer on again. We don't want any of this dropping down into the windings, do it? Tiny little nut. These are quarter nuts. And realistically, right, they don't need to be tight. They need to be secure, but not tight. Blue wire goes to the second terminal. Blue wire, which is your neutral in single phase. It's going to play nicely as our second phase in this case, except it's just single phase, so it's still neutral, isn't it? Okay, now this blue wire now comes to our third terminal. Little washer on. I keep looking for Pops there, because Pops has been visiting me. He's been coming in through the door, coming asking for food. That's what all the squawking is. It's the bloody it's the starlings. Right, I need what earth on in there. Like that. Oh, sorry, I bumped you. Wait a minute. Stop you wobbling. It's because I've got you on a bit of a springboard. So you can get out over here and see what's going on. Okay, that's what wired up. So, live coming in to our, this will be A2, B1 terminal. Because the circuit goes from this terminal to that terminal to that terminal, back to that terminal. Okay, we've got that wired up. Now, moment of truth. Plug it in, switch it on, let's see what happens. Plug it in, let's get my little meter ready. Because I do want to measure the voltages across the phase. Now, what I'm also going to do, just going to get a drop of oil. I'm going to put a drop of oil in the bottom of there to lubricate the shaft in the gland, because I don't want it running dry. Okay, we're going to switch this on, see if it runs. success. Let's measure our voltages. .240 .270 across that line, .280 on that line. What you've got to watch for as well is the heat. If this is running in reverse, what you can do, you can switch the brown wire, the input to the capacitor, to your neutral terminal in there. So neutral, so you go 3 to 4 instead of 2 to 4. And that will reverse the flow of the motor. You'll not know that until you pop it in a bucket of water. However, this pump's got a bit of 4-foot head on it, static head, because it's got to pump it up into the top of the lathe, hasn't it, into the delivery tubes at the top of the head. So if I test this with the top open, chances are the liquid's going to come up and straight back down into it. Electricity and water don't mix very well. So, job done. We're happy with that there, that it's running. What we need to do now is we'll take our little tube, our little extension piece off. We'll pop it back into the machine. We'll wire it up on the existing wiring that's in the machine, and we'll fish that wiring out at the switch. And as I said previously, I might move that in there. I might. We'll see. A little thing for future Barry, isn't it? Okay. The only thing I'm concerned about a little bit is the high voltages on leg 2 and 3. 280 volts is supposed to... I wonder if we went for a 4 farad, whether that would make a difference. I might order a 4, they're only £7. I might order a 4 farad one anyway and test it and see what it does. I would like to pull them voltages back to be more in line. Anyway guys, that's it for this video. We're going to pop this back together, we're going to put it back in there, and we're going to test run it in there and see if we can push fluid up, see what we can do. First little job for the lathe will be making a replacement little thumb wheel like this, and it's for the indexing numbers, which for thread cutting. For whatever reason it's getting lost. I've got it held on with just a nut, but you are supposed to be able to just loosen it and remove it from the thread, from the lead screw, in order to cut down the wear on it. I'll probably not do that anyway, but it'd be nice to put the little thumb wheel back on. So that's our first little job on the lathe coming up, and then probably in the next video. Right guys, thanks very much for visiting. As always, your time is greatly appreciated when you come visiting us to see what we're up to. But remember, don't overthink it. It's only nuts and bolts. Catch us in the next one. Ta-da now.